what I didn't want. I wanted to start recording and then yeah, okay. So do not hesitate to raise your hand or put a message on the chat saying, I please slow down, and I will. It's just that I sometimes do not care about, I mean, I do not realize that I'm speaking fast. And this is why I sometimes use the captions, but the captions is, I'm not, since I'm not a native speaker, are somehow not very efficient in translating, but so please do tell me. The other comment that was regarding the amount of and the speed of the work. I am not used to work with undergraduate students, so normally I mean, the pace is the pace that I'm used to have when I teach, because I do not teach very often with graduate students, so I understand that the pace is different. So I will try to disseminate the readings, etc., with some space, so that you do not feel that you are overwhelmed with the different activities. Anyway, you have to consider that these are two courses, okay? So I cannot rely on the fact that I have given some homework in the other one and that I cannot give a homework in this one. So of course, I will try to schedule the different homeworks so that you can keep up with the pace and do not feel that you are overwhelmed. So that was another comment that I have. I will do that as much as possible, okay? Because there's a lot of material. Of course, I cannot teach everything about cloud and big data, but it's important that you do things particularly, and this I come to my next comment, because this course is graded in a very different approach to the ones that you are used to, okay? The approaches that you are used to is that there are classes, there are homeworks, and everything that you do is graded and counts in your final grade. This is not the case in this course. All the readings, all the little exercises that we do are, I mean, I try to give feedback, but they do not count in the final grade, okay? This is for free. You're doing things for free. I mean, not for free because you are building your knowledge, okay? But it will never count in the final grade. Okay, so if you do not read because you didn't have time, this doesn't matter. I mean, it's just that in order to be able to participate and to follow what we are discussing, it's good that you read beforehand, that you do the exercise, etc., because there is a lot of material and a very diverse material. So you might feel that if you do not this, you might feel a little bit lost with all this diverse material that we are addressing. This is why it is important that you do homework, but in any case, think that this counts. Okay, so and then anyway, in the Blackboard, particularly in the lab, there was the homeworks, the first homeworks that you did had appeared in the grading table, and everyone has one. One means, again, in the table you are seeing points, you are not seeing grades. So one means that you handed in the work and you have one. Okay, one, it's like check. I saw that you had the work done and it was there, and we discussed it, but that's the only thing that this represents. This doesn't represent a grade or whatever. Okay, this is for the non-graded activities. And then for the grades regarding the hands-on that you handed in. That one, again, this is points. You have to consider for it. I think that it was 15 points, no? So you have at the moment, let's say 8/15 points. Again, this is not a grade, these are just points. And then I have explained many times, I think that there are some of you that didn't get the message. You handed in the hands-on, now you have feedback and you have a certain number of points. But I'm asking you to revisit your report according to the comments that I gave in the report so that you can improve the report and get further points in the next round. Okay, so at the end, now you have 8, but if you do extra work and the work is fine, then you can have more points. I don't know if the remaining points to get to 15, but anyway, you will increase the number of points. So do not get a heart attack if you have 1 or you have 2 or whatever. There is another chance, according to my comments, to improve your work and then get more points. Okay, so it's something that you have to consider. And again, the principle is I am building my knowledge. I was able to do something at some point until the deadline. I handed in that. I receive feedback, and according to the feedback, I improve my work, and then I will receive more points or less points now, but more points, yes. Okay, so that's the only thing that matters. So again, do not get worried. And so and then you are I know the system because I'm Mexican and I even studied at lab, so you have clarifications and things like that. What is the point? I mean, if you want to clarify the grade, I would say that this is nonsense. Clarify the comments. Okay, so if you do not understand that comment that I made because I went fast or because it's not clear for you what you really have to do not hesitate, contact me on Slack, and then we can build up according to the thing that you did, well, how you can improve it. It's also possible that I give comments and you say, well, yes, this is great, but I don't know how to improve my work. So in that case, that is a moment where you contact me and you ask me, okay, I am figuring this, but I'm not sure whether this is what I need to do in order to improve my work. And then we can work together in that sense, okay? And the final comment is that some of you, I think that 3 of you didn't hand in the work for the lab first round. So do in the second round, which is the deadline is next Monday. But the only problem is that you will, of course, you will have feedback, that's for sure, but you will not have the possibility to improve because there are only 2 rounds for each graded task. But anyway, if you forgot, if you couldn't make it or whatever, well, in the second round, please do, so that you do not lose points, because that homework is graded and that one will count, okay? So do that. So again, I see that the system says at some point that you are late. I do not really care if you handed in the report at 24 or at 23:55. I'm not a computer. So you can, even if the system doesn't allow you to hand in, I mean, in a reasonable time, I mean, some hours or a day or whatever, then share a link and then that's it. Okay. Even if you are not making it, share the link on the Blackboard and then complete your work afterwards, and I will accept this. I mean, the important thing is, again, that you build your knowledge, and despite the fact that you might have some delays, do not exaggerate, because I mean it's pointless, but do that. And so that you can get the points. Okay, so is that clear? So for the time being, you have had the lab. I'm finishing the evaluation of the theory, and again, at some point you will see that you have points. Do not get a heart attack. Wait until I say, okay, these are the points that you have, and this is how you can improve your work. Okay. And there was a final comment saying that there is an overlap between the content of the lab and the content of the theory course. That is normal. It's the same. It's the same course. I mean, it's just that we are practicing more or in a deeper manner in the lab some aspects that we see in theory, but I mean, of course they are related, and of course the material is related, and that is good because in that way we can have both perspectives, both the theory, even if theory is light in our case, but there is theory anyway, and then the labs are the labs. But I mean, of course, this is the same, and it cannot change because I cannot invent two contents of the same topic, and it wouldn't make sense anyway. And then the Kahoot story, yes, I will try to use Kahoot. There was a comment about Kahoot or similar to make trivias. I will try to use that to do some trivias and make sure that we have fun and that we share our knowledge and test our knowledge. Right. Okay. So while I stop sharing this whiteboard, and I go back to content, please do not hesitate to ask questions now. And here is a Blackboard. I have to share the screen. I think, yes, please, Carlos.
Doctor, could it be possible to talk with you at the end of the session because I have some doubts regarding my notes?
Yes, of course. Or
Thank
contact
you,
me on
doctor.
Slack if you, or the way you want. I'm not sure that I'm registering. Oh, yes, I am. Okay. And you're having a look at my screen? You aren't, no?
No, we can't.
And now
Not really.
I changed computer, and now
No, we're just seeing your webcam.
you are seeing only my webcam. Yeah, right. Um, what did I do? So share the screen, please. Share my screen. I think you have to be a little bit patient because this thing doesn't want to share my screen. Oh, I have no, so that's a Blackboard and it shares, and then when I want to share, I don't know what, open Microsoft, let's say. Mm -mm. Let's try with this one. All right. But if you add Microsoft PowerPoint, and now still not. Just one. Okay. Right, maybe Uh, I am going to disconnect and come back because otherwise it won't let me share. So just be patient 1 second.
Yes, doctor, don't worry.
Sure thing. No problem.
Victor,
So now I'm back. And then it's going to work. Yes, right. Okay, so today we are going to do two things. First of all, we are going to discuss, in order to wrap up, the two exercises that we did regarding experiments, I mean data science queries. As I said, these were very simple examples in order to make sure that you are aware of the way these type of queries are answered, and that we use, well, in our case, we only use statistics in order to address research questions. And I only said that other questions can be answered using machine learning or artificial intelligence operations, but I decided not to go through this in a deep manner because you already have an artificial intelligence course, and particularly because here we are interested in configuring the environment, executing, understanding architectures, etc., much more than addressing big data analytics in the sense of data science, okay? But anyway, the objective was to introduce you with this, with the pipeline, okay? So what you have to bear in mind regarding the two exercises that we did on Kaggle is the type of, the principle of defining a pipeline in order to answer a research question. So that's the first thing. And the second thing is that the type of questions that we answer are questions that it is not possible to answer in using classic querying, okay? Neither relational nor NoSQL. These are other types of queries that require another procedure in order to be answered. And this procedure is this step-by-step query where we produce intermediate results by operating on the data, and these results help us to conclude about a possible answer to a research question. And possible because it will never be definitive, okay? So that's what we have to bear in mind. So regarding the analytics experiment, I am curious about what you concluded with respect, particularly with respect to the second one, the one that explored gender gap. So if someone wants to open the mic or share the screen in order that you show what you did, and at the end what was possible to conclude with applying these descriptive statistics and with the data that we have. So who says me? Even if you didn't finish, I mean, until the step that you executed, what were the conclusions? Please, Mauricio.
Well, what I saw, first of all, is that
Do you want to share a screen or something?
no, I have it more in my head.
Okay.
So,
Okay.
okay. Well, first of all, we have two versions: the one without outliners and the one with outliners.
Outliers.
Outliers. Yes, sorry. So in the first one, well, comparing the first one to the second one, we saw that the difference in age was the mean was more separated or distributed. I don't know how to say it, because they were
Mhm.
more different in age. And also, I
Yes.
also conclude that women get promoted in a younger age than men.
Mhm. When we when we didn't impute outliers. Is that right? Or in
Well,
both cases?
in no, when we without outliers, yeah, yes, without outliers. You have
Without outliers. And with outliers,
I don't remember.
you can open your Kaggle and have a look.
Okay. Um, Let me see.
The caption says you can open your castle.
Mm, No, se borró.
No, that's not possible.
Oh, let me check if I go to edit, because I yesterday I run all the commands, but I don't know why it didn't show.
Ah,
But let me
yes,
check.
because it doesn't keep the state until if it's draft, it doesn't keep the state until you say that that's the final state, and then it stores it. If someone
Oh, okay.
executed that too, you can
No, I don't.
intervene
I
too.
think
Which step exactly? Because I have several. Like I say.
The one, well, what Mauricio said is that regarding age, one of the conclusions was that women were promoted earlier than men. And what we are trying to figure out is whether this happened when there were outliers and by by imputing outliers. If in whether in both cases women were promoted earlier than men. For those that are silent, remember that there were kind of three guiding variables that determined our conclusions. First one, it was the age. Second, it was the number of observations regarding men and women. And the third one was the location. Okay, so these were three attributes that we have to figure out how to deal with them in order to make sure that our conclusions were representative, at least, of the observations that we have. So when we addressed age, if you remember, when we plotted, the plot was skewed to the left. But anyway, there were people with 90 years, but only 3, and then 1 person with 80. And if you remember your statistics courses, if we keep this by computing the mean, the mean is not very representative, because everything that is very and outside the curve perturbs the mean. So through the exercise, what was proposed is to eliminate, in fact, imputing by eliminating these kind of outliers. But the question is whether, eliminating or not, we could conclude anyway out of that collection that women were promoted earlier than men. And were they? Come on, guys. If you do not participate, things get complex.
Can you repeat the question again?
Yes, I am asking whether we could conclude the same conclusion that women are promoted earlier than men when we kept outliers, and when we decided to impute outliers by eliminating them. So in order to answer, you have to go to your Kaggle notebook and run it again, or run it until that point, and then see.
Yes, I'm gonna run it.
Okay. So while you are running and having a look, then another thing is that at some point we reasoned in terms of proportions, no? Because we had seen that anyway the collection contained more data about men than women. So what is important that you get from the exercise is that it played with the proportions and then with the outliers and other measures in order to solve this problem and ensure that the conclusion, reduce the bias of the conclusion. That's the idea. So while you are running, the other question, that one without running the notebook, you can answer what would be the steps, so the pipeline that was implemented in this exercise in order to reach an answer. So can anyone elaborate on this? No one can elaborate on this.
Can you repeat the question, doctor? Because I
Yes. Well, the exercise has many steps. So the
yes.
idea is, so can you resume the steps that were taken in order to reach the answer? What was the
Okay.
strategy? First we, then we.
Well, first, well, I think it's pretty obvious, but we extracted the data from the file.
Yes. Okay, so fetch, no?
Yeah,
We get
fetching
the
data.
data from the, okay.
And then from that data, we created the data frame.
Okay.
Next, let's see.
So those that are strategic are now with their books or their notebooks, drawing the pipeline, because the next thing is, of course, that I'm going to ask you to send me the pipeline. Okay, so fetch, then prepare transformation, which is producing a data frame. That's right.
And
What
then
was
the
it?
next step,
It was
well,
the
I think
exploratory data analysis, right?
Right, and what it consists of what? What did we do first?
We got the mean, the deviation,
Yes, and what was that? What did we want to do with that?
um, to get the population distribution.
Right, okay. So we wanted to understand, well, since the question was men and women and in different countries, so we started having a look at the distribution of the data with respect to these references, okay? Men and women, that's clear because the question asks this. But then country and then age, okay? So these are the four elements, perspectives that we used in order to explore the data and understand the content. Of course, I'm saying understand not in a semantic manner, in a mathematical perspective, okay? Understanding a data collection from the statistical point of view is exactly that. Understand which are the guiding variables that we'll use in order to answer the question, and then observe how are the values, how are they can behave with respect to these variables. Do you see that?
yes.
Yes? Do not hesitate to, those that are always silent, do not hesitate to write either on the chat, on the Slack, or open your mics. Otherwise, you do not learn. So please do. And I tend not to ask directly because I don't want to, I mean, I want to respect your privacy and your autonomy. But just note that it's not a strategic way of acting, not participating in the class. Okay, so that's just a comment behind the scenes. Okay, so the first thing is, so I go back to the idea that we are elaborating. One is the loading, in fact, no, which is fetching the file with the data, and then transformation, which is converting it into tabular representation. And why tabular? Because it is easier for us to observe the different variables that compose our observations. This is why we use tables, because we are humans and it's easier for us to have a look like that in an organized manner. Then the second step, that's behind the scenes, since we are very clever and we know the question. So we observe in the structure that these variables are key in order to answer the research question. And so we go and explore the data collection with respect to these 4 variables, which are age, gender, well, sex, not gender, because it's binary, country, and age. And of course, salary. Okay, salary comes like in more or less behind the scenes, but salary is in fact the variable that we are looking for. We are looking for the way salary is determined by the variables that we have enumerated now. Okay, so that's important to understand out of the reasoning proposed by the exercise. Okay, so exploration is that, and this is why we compute statistical measures with this. What are we looking for when we compute these measures? Sorry. We are trying to observe the mathematical properties of the data. Okay? What we have said, whether there are outliers or not, how are the values distributed, because this provides us with elements, gives elements to the next decision that we have to do, and which is engineering data collection in order to start figuring out whether we can drive conclusions out of it. Okay, so engineering means whether there are outliers, null values, etc. Okay.
Doctor.
Yes.
Yeah, I have a question, but isn't it like bad for the analysis to delete the outliers? Because, well, like
that's a good question.
well, I think
it depends.
Well, my idea was like my argument that I came up with is like there's always like the outliers. Like for example, I was thinking of a Gaussian function, or like in Spanish it's called la campana de Gauss, which is the bell. Like there's always like outliers, no? Like almost in every
yes.
like
and what
collection
do
of
we
data.
learn in statistics out of that?
Well, I don't really know what you want to like. I know the answer, but let me just say something that like what I do know is that outliers like affect the
Of course,
mean
they
like
affect.
greatly
Yes,
because they're the outliers.
they do. And the question is whether you are going to accept this or not. And a decision that often analytics makes, and that's something that we learn in statistics, is to only get the center of the plot,
Where all that concentration is, right?
yes, exactly.
Oh, I see.
So, but this is well, this has been discussed and and demonstrated mathematically in statistics. But that's the principle of the idea that you are going to impute outliers, is that one, the one that we learn in statistics, that since you have the most concentration in the center of the plot, then you are going to, this is the most representative elements, and therefore you have means in order to drive conclusions, because in the outlier parts there is few data, so it's not possible to drive conclusions out of these little samples that are not very representative of your observation.
Oh, I see.
You see? And then, but the question, and I mean the real question, is whether what lies in the queue is a real outlier that is not meaningful, or is it an outlier that that is meaningful? If you decree that the outlier is not meaningful, then you eliminate it. This is what we did. We declared that since there are few people working at 90 or at 80 years old, and there is few people, and also behind the scenes, we consider that these are no longer economically active people, in fact. Okay, so we can, it's acceptable that we eliminate them from the collection, from the observation.
I see. But in that case, yes.
If we thought that, yes, ask and
No,
then I continue.
no, go ahead.
Sorry. If we consider that these were important observations, that do not want to eliminate them, then we can work with interpolation or extrapolation in order to get them into the representative observations.
Yeah, that was exactly what I was going to ask about the like the interpolation part.
Yes.
Of the outliers.
So when you consider, let's consider, for example, observations in the energy consumption at home. No? Even if there are outliers, for example, imagine that you left the window open, and so one of the readings of your sensors is that it's very cold, but it's very cold, of course, because you have the window open and your sensor is closed, so it's counting, I don't know, 0 degrees. And then in the living room, you have 15 degrees or 20 degrees. Yet, the fact that you do not see the temperature close to the window is not very good if you are, for example, deciding whether you should do architectural changes in order to be sustainable at home. So it wouldn't be a good idea that you eliminate those, but because these are representative observations, even if they are outliers. So what you could do is work with these outliers and put them inside, or try to figure out how to integrate them in the observations so that you do not lose information that is relevant for your study.
Oh, I see.
You see? And this is why you have to know the context. I mean, here we are like in blind thing where, yes, we knew that there were observations and the description told us about the data, but they didn't tell us about the conditions in which they were collected, what was the, and this is why we are like in a very imposed that we decree that these outliers are not representative for it. I mean, in a real study, this doesn't happen like this. And if it happens, because it happens, then it will be dangerous. You see, for example, when Trump was in office, he said that Latinos, we were criminals, no, and murderers. And he was right out of the observations that he used, I mean, or his team did. But this is a very, so what they did is, of course, there were, yes, so they eliminated all those people that are working good, etc., because we don't even know if they were observed in the collection. They just eliminated them, and they kept the data that come from prisons, etc. And so with that, they concluded something. The experiment is correctly done. Mathematically it works, and there is no problem with that. The problem is that this was done in a very brutal manner, and so it drove to these conclusions. Now, the problem with this type of queries is that conclusions can be dangerous, because in that way you bias the opinion that you have, for example, from this community. But this gets out of our expertise. Okay, if we consider that we are computer scientists or computer engineers, this is something that has to be done with a statistician. Okay, and the only thing that we have to do is understand the steps and make sure that the steps are run correctly and efficiently, and on top of that, we do not say, since I don't have main memory, I'm going to exclude a piece of the data collection, because anyway I cannot run everything here. Okay, so this is something that we cannot say. And the other one will give us, I mean, yeah, of course the person has to explain, because in that way now we could see the pipeline in a very, the first try. Then we could see, for example, that we can factorize some operations, that this can be done in parallel with this, etc. Because from our point of view, what we want to do is that this runs in an efficient manner and exploiting the minimum resources, because we are on the cloud and the resources have a cost. Okay, but the other person has to explain the principle, and we have to understand the pipeline, because maybe we are factorizing or we are parallelizing something that blurs the result, and this is not acceptable. Does this make sense?
Yes, it does.
Okay. So what it's important that at home you do is go back to the notebook and try, I mean, follow the steps and draw a pipeline, and see whether there are exactly what I'm saying, whether there are some operations that could be done in parallel. In fact, the pipeline has two main branches. Right? The branch that drives a first conclusion without doing anything with respect to outliers, etc., and the branch that does it without outliers. Okay, and the first exploration branches, and the first exploration branch, in fact, is the so you have like this one branch initially, and then it splits into two branches, and out of that both branches you obtain the result and you score it. Because what is interesting about this exercise is that at the end it scores the result, so you have the whole set of phases of the analytics query, only just with this exercise. So that's what, from our point of view, we have to do and understand. Because, of course, every activity will become a process. And so the question is now, once you have this, where are you going to deploy your processes? Where are you going to split the data across a cluster or not? Whether this can be parallelized or not, etc. So you see a lot of the IOs of the and the data dependencies of the activity. So this is our work. This is our experience, and it is there where we are going to come and say, okay, you know statistics, and that's wonderful, but now since you want to run it on top of a computing support. Now it's me that has to decide how to deploy it and make sure that it runs correctly. Right? Questions until here? Kernel density. From the exercise. Yes. Let me going to let me think whether I'm going to do that now or whether I'm going to send a document before I explain this. Yes, that's a good question. How many of you do remember the concept of kernel density, the limit theorem, Pearson's score, all these? Well, the first question is whether you studied that in statistics or you did.
It doesn't sound familiar to me. I don't know if we saw it.
No, in Spanish is el teorema de límites. No? I suppose that you studied in Spanish statistics. Okay, so I'm not going to explain this because in order for me to explain kernel density, I have to go through a set of concepts that you need to understand before I explain this. So there are two things that that I'm going to do like in parentheses. This is one, and the other that I still have to do is NGDoc, okay? So what I will do is, I don't know, maybe, well, at some point I will send some reading, and then we will have like a parenthesis session with one with these statistical issues and the other with NGDoc, which is, that one is useful for the next steps. But anyway, okay, so that's what I'm going to do if you do not remember, which is the case. So you just have one course of statistics, probability and statistics, or only statistics?
Probability and statistics.
And statistics, okay, only one.
Yes, only one.
Okay. And did you like it? Or you hated it?
I think I didn't get a good teacher, so I mean, I enjoy the probability aspect, but the statistic part, not
It
a
was,
lot.
so you prefer probability than statistics, okay.
Yeah.
Right. And the others?
I didn't like it either because I got a teacher that she made us memorize everything that we needed to do in the partial exams. So all the formulas and all those things, we needed to have them memorized, and it was a lot of information. Plus, it was the time when we started having online courses. So
Okay, so it was not very friendly.
yeah, no.
And but did you understand how do we as computer engineers study probability and statistics?
Not quite.
Okay,
I
so
think the problem with our course is that it wasn't focused on engineering. It was more like a general, like for general areas of study. So it wasn't like focused on engineering, and so we didn't get to learn how computers do probability
no,
and
that's
statistics.
normal. I mean, maybe for other engineering disciplines it's possible, but for computing engineering, I would be surprised that having such a thing. Okay, so you do not know why is it important for us to have this knowledge? you can skip statistics and live happy in your lives.
I mean, I think that the reason is basically because one of the main concepts, well,
No,
one
but
of the,
don't tell me about the reason. Tell me your opinion.
oh, well,
It's valid that you say, I really don't see why is it useful for me.
no, I
Okay,
do, because
okay,
since we're managing a lot of data, we need to see the best ways of organizing it in order for us to see a pattern or a good distribution. And that's one of the that's like what I remember from that course. I learned that if you
so you
organize
saw
your,
data in the course. Okay.
yeah, if I learned
Mhm.
that if I sorted my data in a good way, I would get a graph and a distribution that it would be easier for me to understand and to manage than if
Okay.
I just organize it in the way that I think it's the best for me.
Okay. Okay. So we will do that. Um, Maybe even, I mean, before next time, I will prepare that for you. Um, and of course, maybe with applications that you can see in which way you can get the most of such a knowledge. Okay, so that's a parenthesis. So you keep your question on your bag, on the stack, and then I will pop it, right? Okay, so, and well, anyway, so as I said, this serves me to continue with the topic that I want to open today. I didn't put my, I have 10 minutes, I think, no, because this is the lab. Okay, so I still have time. As I want to insist on this because it is important that you connect what we are doing in on the lab is, again, we have seen these two examples of pipelines of analytics, and our role will be to decide many things. Decide, for example, the cost of the different, once you, defining the pipeline is like getting the X-ray of something that a person defined without thinking about a pipeline. Okay, so the person would give the notebook, and then you as computing engineers will have to extract out of that the pipeline. Okay, and once you have this organization, in fact it is a combination of control flow and data flow. Once you have it, then the first thing that you have to do is estimate the resources required in order to execute such a thing. Okay, uh, with respect to the complexity of the operations that are performed in every step. Okay, because knowing the complexity will help you determine like intervals. And I will have data, an amount of data from here to here, I will need just a CPU of these characteristics in order to execute the pipeline. But if the data increases in volume, then I will need X number of CPUs, of GPUs, etc., because otherwise it will take a lot of time to do that, or it will consume more memory, and I want to also reduce memory because memory has a cost. Okay, so I will our work as computing engineers is estimate the cost in terms of resources of the pipeline that is provided through a notebook. Okay. And once we do that, then we can decide, of course, the type of architecture that we need, and then the strategies in order to make it run efficiently. Okay, because, well, normally these are the two things that we seek for in our solutions. Okay, the third thing would be how do we maintain it, but that's a separate problem. Okay, so at least these two things with the initial notebook, that is what we need to extract. Okay, so today the extraction of pipelines is in its early stage, but there are already solutions that, for example, process the notebook and produces an execution plan. Okay, so that we can then make such type of decisions. And so if we want to execute it, then we have to go and see the different operations that it applies. And a thing that we have decided when we want to ensure performance is whether these operations should be run in a centralized or in a parallel manner. Okay, and so the next topic that we are going to address is exactly this, which is how to eventually parallelize the operations that are referred to and used in an activity of pipeline. Okay, so in that way we are connecting with what people external non-computing engineers do when they want to define their pipelines. And so I'm going to do, well, a second try with MapReduce and with an exercise that will, I hope, will make clear what we did in the theory lecture. So we are going to assume for the time being that we need to parallelize, okay? Then once we have had experience on this, then I will show you which are the criteria to consider in order to decide whether to parallelize or not. But let's suppose that we are going to parallelize and that we want to make it more or less simple, okay? So we are going to use simplified parallelization models in order to do that. And so the question and what we are going to start doing is designing parallel algorithms using the MapReduce model. So here a bit of disclaimer. Some tasks of the lab will be like exercises, okay? So it's algorithmic, but we have to design and reason about the algorithm. And of course, some other parts will be deploying our algorithm and running it in different on different technologies, on different infrastructures, okay? So it will be a little bit of hard time. I tell you beforehand so that you do not feel frustrated, okay? So at any moment that you feel lost, you say, okay, here in the other parts, it was more in your comfort zone. Here, I believe that we are going to go out of your comfort zone, so do not get angry with me and do not feel that, oh, this is nonsense and I cannot address this. It's a lot about being patient and a lot about asking questions, and never feel that questions are naive or whatever, because we have to rearrange our brain in order to address this, okay? So just this disclaimer so that we don't get frustrated with that. Okay, so in the other course, what we saw is that this MapReduce model, in fact, it's very restrictive. I mean, I don't know why didn't you ask me whether this was even possible to do this, okay? Because note that anything that we want to do must go into functions, okay? So, but anyway, we are going to rely in the use of two functions, map and reduce, in order to implement almost any of the algorithms that we know until now. And we will use, as we said in the in the theory lecture, a data model, a key value data model, in order to model our data. Okay, the data that these two functions will use. So let's have an example in order to get the intuition. So consider that we have a micro document, which is here on the left. So this micro document has two sentences. One is C Bob throw and C spot run. Okay, they do not have any meaning in English. But this is imagine a document. So and we want to count the number of times that each of the term appears within the document. Okay? So first thing is, so it's like a recipe. Okay, so first thing we have to, this is raw data, we have to determine how are we going to model this data into a key value structure, according to the thing that we want to do, which is counting the number of times that a word appears in the document. So a strategy would be to have use as key every term, okay, and then use as value the fact that the term appears in the document. Okay, so it's a very simplified way. Okay, and then we will discuss on more intelligent ways of addressing. Okay, so I will say that my document will be represented as tuples, where the first tuple is a term, and the first element of my tuple is a term, and the second element of my tuple is 0 or 1. Well, 0, no, it's just 1, okay? Because it appears. And so I am going an algorithm, a very simple one, that will do the following. It takes a term and it builds a tuple with the term and the number 1. Okay, so it goes through the document term by term. It takes the term, it opens a tuple, it puts the in the first attribute the term, and in the second attribute number 1. Like that. Pip, 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 pip. I don't know if we have a question. Okay. So if we do that, so we get without thinking in parallel or nothing, just think about this function. So the function receives this entry, and so I go for the first term, and I build my tuple C with 1. The second term is Bob. I say in my tuple Bob, this is the key, and 1 is its value. Throw, this is the key, and this is my value. I have a C again, it doesn't matter. I get the term and I get the value. Spot, I get the term and I get the value, and run, I get the term and I get the value. So now I have a list of term value in my first try, okay? Now, in my second try, since I know that there are terms that appear more than once, because I am looking for the number of times that a term appears. So the hypothesis is that a term can appear more than once in my document. So what I will go and see is I'm going to produce a new list of key value tuples, but this time I am going to, in my value, is going to be a tuple itself. And I will keep like a little stack. So I get my term and I get its value. And I continue like that. But if I get a term that is already in my list, instead of having a new tuple, I will add its value to my array. Okay? In that way, I will produce a new codification of my data. So I come and I write the corresponding algorithm. So I will get this tuple. I use, well, here is the result already organized. So I will get C, and at the first try, it would have a 1. Then I go with Bob, and it has a 1. I go with Throw, it has a 1. But then comes C again. But C is already in my list. So instead of creating a tuple, I add an element to the value of the term of this key. And then I continue and so on and so forth. And I end up with this new key value tuples, this list of key value tuples, but in this time, my value is an array of ones. And then once I have this, I am going to, because I remember that I want to count, okay? So what I will do is I will go through the list again, and then I will take the value and I will do the summation of my ones. So I will say, Bob, the summation of the elements of this array is 1. Ron, sorry, the summation of this array is 1. I get C, and then the summation of this array is 1 plus 1 is 2. Then Spot is 1, and Throw is 1. And now I have, again, a new key value tuples, where the first tuple represents the term, and the second, and the value, the corresponding value, represents count, the number of times that the term appears in my document. Is the logic clear until now?
Yes, doctor.
Yes?
Yes, very clear.
The question is whether we could imagine this, but well, it's already done, so don't have to imagine that for the time. So this is the general idea. Then how does it look like in more technical terms? Not see for the time being these phases. I will go back to them later on. So this is the general logic of the solution. And then, well, not later on, just now. So what I have to decide is, well, I have this this algorithm will implement the map function, and this algorithm, the map function will produce this result, and the reduce function will implement the second algorithm, and it will produce this result. Okay, so here the first one is the map function, and the second one that processes the result of the map is the second function, so the reduce function. Right? Clear like water?
Yes.
I'm gonna support this. Okay. Now, in terms, I hate this. Just wait a minute. Otherwise, I will not live my life happy. So, in terms of a pseudocode, and supposing that we are using an object-oriented language in order to implement these algorithms, so I would have a class mapper with my function map that gets a document like the one I presented previously, and so the ID of the document and then the document. Okay, so in my example, I just have one document. Imagine that we have collections of documents, so you are going to get the ID of the first document and of course its content. Okay, you can imagine web pages, so the ID is the URL and the content of the page. And so here, I mean, it's not a very complex algorithm to implement, so I'm going to say that for all terms within the document, I will produce a tuple. So I'm going to construct a data structure that uses with two elements. The first one is the term that I get, and the second is 1. Okay. And then the reducer, the method, contains the class reducer, contains a function reduce that receives this data structure, the one that I presented. So I receive term and I receive my array of ones. And what I do is I start a variable 0, and then for all the counts within the value of the term, I'm going to do the summation. And then the result will be my term with the result of sum that contains the summation of the value of sum that contains the summation of the ones within the array. Easy. I'm not going to, well, yes. So which are the problems of this? The problem of this is, first of all, that if you have a look at the document, the list that produces map is not organized. I mean, the first one, the one with the duplicated terms, the problem is that it is not ordered, and that it also does not take care about the duplications. Okay, so the idea would be maybe to have a more intelligent map function that considers already the duplicates. Okay, so that from one shot it produces the complex array of ones that I have, instead of having two steps, one with duplicated terms and then a process that aggregates duplications and creates my data structure with ones. Okay, so these are two design possibilities that I can consider. Either I just keep it simple and have a little dull, not very smart map function where I have this. And then I consider that I delegate to another intermediate process this reorganization of the data, such that when the reducer comes, it receives already the new data structures with the ones within an array. Okay, so what is best? Well, we have to think about resources. If we keep the map and the reduce in a very simple manner, this means that the execution of the map will not be very costly, and that the intermediate step between both functions will take care of this. So I will delegate to the running infrastructure to do that. Okay, so I will not see this overhead will be delegated to the infrastructure and not to my program. Okay. But the problem with the infrastructure is that I create overhead on the infrastructure. So maybe it would be better to have a more complex map function and already produce this, and then just have very few reorganization in delegated to the infrastructure. Okay. So these are the design problems that me as programmer has to decide and to solve in order to make sure that I have the best map reduce setting in order to solve my problem. Okay. So this reorganization part phase is called shuffle and sort. So because it aggregates and also because it orders, okay, the data. And this is normally done by the infrastructure. So you as programmer has to do this, and the organization is left to the infrastructure. But if you want to be clever and you do not want to delegate too much things to the infrastructure, then you have to start figuring out whether some of the operations that are done this could not be already done within the map function. Okay, so that's the type of decision making that you have to do to make. So and so this intermediate part, of course, is done by processes. Okay, so between map and reduce, you will have 3 reorganization processes: shuffle, sort, that are implemented by two processes that are implemented by what we call combiners. Okay, so in the infrastructure, you will have these 3 processes running in order to deal with your map reduce solution. So I will not get there, but I am going to get here. So in fact, what happens is, do not see the left side. So the little pipeline of execution of your setting, now that we have this initial thing, is that there is a part of initialization of the data. Okay. Then they are fed to the map function. Then the result is given to a shuffle and sort process, and then there is the reduce function that operates on top of the new results, and then it goes to the disk again. Okay. Now, and here you would say, well, and what is the parallelism in fact? Okay. Well, the parallelism will happen I'm going to stay here. The parallelism will happen because we are going to divide the initial collection into groups, okay? Like if I have 3 initial collections rather than 1. And these pieces of collection will be used, or will be the input of my map function. And so, and of course of my reduce. So these, the map and the reduce function are operating on a subset of the initial data collection that I provide to be processed, okay? And since this can be independent, so every independent piece of data on top of which I apply map and reduce will run in a different node within a cluster. So that's very, I think it's very intuitive to do. Questions until here? Please, Alexander.
Thank you. Excuse me, can you repeat that last part about what runs in each cluster? I couldn't listen well.
Yes. I'm going to go back to my figure here so that I can explain. And I'm going to do the following. Well, here is my initial data collection, with C and Bob and etc. Imagine that what I do is the following. Is that I divide my collection, my super big collection, into 2 pieces. One is this piece and one is this piece. Okay, now I have 2 pieces of the initial collection. And I'm going to apply the same idea on top of this and the same idea on top of this. This will run in one node, or one node of my cluster, and this will run in another node. Did I answer?
Okay, I think I get it better. Each piece of the document runs in a different node of the cluster.
Yes, you have this piece of document, and you apply the map and the reduce, well, the shuffle and the reduce on this piece, and you get this piece and another node. I am the second node, and so I get this piece, I get my task, and so I apply the same idea only on this piece. And then we have to put everything together. That's another part. Right?
Yes, thank you very much, Doctor.
Yes. Now, of course, here many things to consider. As you can see, one thing is who is going to divide the pieces of collections. And what are the characteristics that my collection must have in order that it makes sense that I divide it like this? Imagine a piece of roll of paper. This means that I can cut the paper at any level of the roll. So my data must be really independent. I cannot have data, for example, in documents. And if we go back to the data model in Mongo, if you use references, you cannot divide the collection in any way because you are going to cut the the elements that have to do together. So this is not possible. So it should be sets of data where the items are independent. Okay, so that's the first thing, so that I should not put I, programmer, should not put intelligence in the way I am going, well, the system is going to divide the data. Otherwise, if this is not the case, there is a preparation step that I have to consider before I apply my MapReduce solution. Okay, so that I cannot delegate to the system. The system just works automatically if I give as a data collection, and it can divide it as it wants, independently of the content, the structure, or whatever. Okay. So that's one thing. The other thing is, of course, deciding about how am I going to design these key value pairs, whether I have who is the key or what is the key, and then whether I have a simple value, for example here, or if I need a data structure to represent my value. And then the other thing is, of course, what are the operations that I'm going to implement in my map function, and what operations am I going to implement in my reduce function in order to make sure that I get a valid result. Okay, so these are the steps to consider. Questions until here before we wrap up? So today well, time is over, but next time what we are going to do is, with this first very simple approach, we are going to go back to an infrastructure, and I'm going to show you how is this implemented, and then how do we run it on top of an infrastructure. Okay, so that you can see in true how does it work. So as I said, the infrastructure that we're going to use is Hadoop. So we are going to install Hadoop and then run this first example. And then next, what we will do is I will give exercises in order that you start getting comfortable with this MapReduce design, so that you implement some, well, you design algorithms implementing classic functions, for example, computing the mean, computing the standard deviation, these kind of things, or computing inverted indexes, but on this type of model, and then so that you can then test them and run them on the infrastructure. So this is an important piece of exercise, technical exercise, that we are going to do the next weeks. Right. So if you do not have questions, we are going to stop here, and I'll see you on Friday. On Friday, since we are now synchronized with the same topic in both syllabi, so what we will do is privilege theory and design aspects in the theory course, so that here we can really play with the infrastructure and see concretely how does it look like. Very good. So I'm going to stop here, and I will stop sharing my screen. And then, of course, I think that by tomorrow you will receive the feedback from the polyglot, etc. Some of you should have seen, because I finished evaluating some of you, but I will have completed, and then we can move forward. I know that at some point, this is my last comment, I know that at some point, of course, you need to have feedback of the grades, because, I mean, it's important, but at some point, you have to decide whether you continue with the course or not. Avoid this, okay? there will be no need that you decide to stop attending the course because of grades. So just bear that in mind. Do not even consider that. It would be pointless. Okay, so see you on Friday. Yes, please, Carl. Ah, yes, we said that we were going to discuss, no? I have like 15 minutes to discuss because then I will have a keynote. But,
Yes, I will be very quick, Doctor.
yeah.
Is that I noticed that my partners, well, all my classmates got a grade on the hands-on, but I didn't.
Okay. Really?
Yes,
Why is that?
I
I
don't
will.
know. I I asked my classmates, and
Yes,
they told.
everyone for the lab, everyone has a grade.
No, no,
I mean, a
no,
partial grade.
not in the lab, in the other course.
And in the other course, it's not finished. No, they don't have a. They only have points for the some of the homeworks, but I have not finished, so this is normal.
Ah, okay.
The grades for the theory course are not there.
Okay, okay. Because
Mhm.
I was worried because I didn't had a grade on the
Yeah, no, do
hands-on
not worry.
partial evaluation.
The grades are incomplete anyway.
Okay, thank you, doctor.
Mhm.
That was
You're
all
welcome.
everything I got to say.
Yeah.
Oh,
So,
no, 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 no. I wanted to say
uh-huh.
something else. Uh,
Uh-huh.
could it be possible for me to have like a private session where we could review my the lacks on my report so that I could improve it
Yes,
in the
of
best
course.
way?
Of course. So contact me on Slack. So that I can schedule. We can schedule some session and we interact. And this is valid for everyone. So have a look at my comments and then contact me on Slack so that if you have further questions, we can interact and you can complete. Yes, of course. So please
Thank
do.
you, doctor.
You're welcome. Yes, Alexander.
Thank you. I also have like a quick question.
Yes.
I just wanted to confirm with you if for the laboratory, if both hands-on one serves as a unit of construction and hands-on one, you understanding externalized settings on the cloud, they're the same activity, aren't they? Do we have to upload it once for each then?
The one, no, that's a difficult question. So for the lab, what you have to do is only one upload, which is the one that you have to draw the functional architectures with S and the processes, and then compare the setting provided by Azure tutorial and the one that we implemented and the glossary. And that was one report.
I see. Yeah, it's because I uploaded only once, but I
Yes,
think
you need to upload only one.
yeah, but I think I was graded on like two hands-on activities, like two hands-on one
Ah,
activity.
there is one, yes, because it's divided, but yes,
So,
the one is, yes, you are graded in two because one was, I don't know, like sending something, and so you have points for that, and then the rest was the real report.
okay, it's because I was reading this. I only uploaded it once because the description was the same for both
Yes, that's
hands.
fine. Everyone uploaded just once.
Ah, okay, yeah, because I was worried because I got a grade on one and the other one I didn't have because I didn't upload because I thought I only needed to
No,
upload.
no, no. You only have to upload one report,
Okay, okay then.
right?
Very well.
But in the other one, you have a grade, no?
Yes,
You
and
have
when
two
I have a
grades.
grade,
I mean, you have two points because this is not a grade. It's just some points for one and
yeah,
another.
exactly. I have points in one, and the other one I have like only 1 point, but it's because I didn't upload because I
Yeah,
didn't know.
because it's like the count.
Ah, okay.
It's just that you were there. That I mean, just tick.
Okay then.
It's
If I
not
have
a
any more,
great,
oh, sorry. I wanted to ask if I had any more questions, can I contact you by Slack?
of course.
Okay,
Slack is always open.
very good. Thank you very much, Doc.
You're welcome. Yes, Luis Felipe.
Yeah, sorry for well, I think you were leaving, but sorry.
Okay, no problem.
I was just wondering because on the first hands-on of the regular class, I have no feedback,
Do
and
not
I got a first.
consider the regular class now because the
Oh,
grades are incomplete there. I have to
okay.
finish grading, and so there is no point of considering anything from the regular class because this is incomplete.
Okay, my bad. I misunderstood there. Sorry.
No,
Okay.
no problem.
Have a nice day,
Mhm.
teacher. Thank you.
You too. Bye bye. Yes, Garrett. I sorry.
Miss, I don't know if I can speak in Spanish for be more clear.
Ajá.
Ok,
Please do.
okay, gracias. Es que tengo una duda sobre la actividad. Es que
Sí.
al parecer, al parecer, bueno, no tengo
Ah,
calificación, la
malvado Garrett,
calificación.
tú eres el que no entregaste
Ajá, de
el
eso quería,
laboratorio.
no, de
Pues
eso quería
súbelo.
comentar. No, es que la indicación
No,
venía
sí,
de que
sí,
subirlo a
súbelo.
una carpeta y yo lo subí a la carpeta, pero no lo
Ah,
subí a
la
Blackboard.
carpeta, a la externa.
Ajá, yo lo subí en la carpeta y no a Blackboard.
Ah, pues mándame la liga y ya la veo y de todas maneras tienes un segundo round.
Ok. Sí, más que nada para el feedback, para poder hacerlo bien en el segundo round.
Sí, sí, sí.
Sí, de acuerdo, muchas gracias.
Mm. Bueno, ahora sí, bye bye.
Have a nice day, doctor. Thank you.
Same to you, bye.